we're going to make a custom subclass of this person object called fellow. And that fellow is going to have a property. That property is going to be called, anyone chime in? It's going to be Burrow. Thank you, Sam, Sarah, and Sunny. So we're going to have a property, Burrow, and we're going to have an instance method, whatStack, which we said will require some IVAR, so some hidden variable, in order to print out the stack. Who wants to get us started? I think this is one of the easier steps. How can we just start creating our own custom subclass? Yes, I'd love to make a new file. Liana, can I get your assistance in making this new file?
You can go to File, New,
Nice.
and do a Cocoa class, and it will make editor in the main file for you.
Awesome. What should I make it a subclass of?
A person.
Interesting. Look at that. So it went and it looked through our files when I was creating a new file and let me create a subclass of something that I've already created. It finds that by looking at our interface. Just going to let us interface with whatever files we have. So what's this guy going to be called, Liana?
Fellow.
Awesome. Making a fellow. Cocoa class creates both the implementation in this .m and it creates the interface in this .h. We're going to get rid of these things. All right. Let's see what they say here. No error. We got rid of those markers. No error there. Great. All right. I think the interface is the easy part. We've got a property. We've got an IVAR. We've got an instance method. Eric M., can you help me set up an IVAR? Eric, why don't you talk me through it?
You said borrow should be type string.
That's actually going to be our property here. But instead, we wanted to create an instance method called stack, and we said we need an IVAR for that. So stay with me. How can we create an IVAR for the stack? Eric? Any ideas?
On the dash parentheses instance type.
like this. Is that what you're referring to?
Yeah.
Okay. What is this actually going to do? This dash indicates something in our interface. Yeah, Sam, let me pull you in here. What is this dash here to indicate to us?
That when you implement it, it's the name of a function and it's a return type.
Yep. So this is what in Swift we call an instance method. It's not quite how we're going to do an IVAR. Levi, what do you suggest?
David, I would suggest right after the definition there at the top that you put some curly braces.
Like that.
Open them up for ease.
Open it up.
And then create a variable there. Let's make it an NS string. I mean, we could also make it a float, but that's messy.
Okay.
No, take out the there and take out the star.
Okay.
And then after that, put a star. Call it stack underscore semicolon.
Underscore semicolon. That.
I like that.
Okay. What do we say about like a naming convention for IVARs before we look at this error?
Oh yeah, just call it stack.
Go ahead.
Don't want to put the underscore before stack, where you're talking naming convention.
Yep. That's correct. I think we're losing you, Leona.
Okay.
Yeah, so for an IVAR, remember that we indicate what in many languages is called a private variable, which we have a private keyword for in Swift. We indicate it's private by using an underscore to start. Dang, though. Jocelyn, I see an error. Do you want to read it with me?
Says unknown type name NS string.
Interesting. Okay. I'm sure we could solve this in some way, but right now our file doesn't know what an NS string is because all we've imported is person. So we only have the interface for a person inside of this file, which only has this object called person that's got some IVARs and all that stuff. So our fellow needs to get some more information from Objective-C on how we can use these other types. Any suggestions? Any verbal suggestions?
Import foundation.
Yeah, let's do it. Why do I need foundation?
To access NS string and NS array and NS stuff.
So foundation is the package that has all in there. Hey, Levi. you think you did something slightly different to make it work on your machine?
Here, David, I don't think we needed to import foundation for the person header file either. And mine works without importing foundation as well.
Interesting. So you didn't need this guy. I think I need it though.
I think for me, I only started recognizing it once I started fleshing things out in the main file.
Tell me a little more about that.
That's it. It at first it didn't recognize in a string, and then once I started typing in the main file, I went back to the header file and it recognized it.
So right in here. How would you debug this? Because now I'm seeing an error in here. I've got an error in my person file too. This
Did
is
you import foundation in the person file before?
aha. No, I pulled it apart because I was being a jerk. I wanted to debug it with you. It wasn't an Objective-C error. It just needed our foundation. So let's see. Will this build now? Yeah. There's a David error. That's right. I'm going to make more of those in this lecture just to see who's paying attention.
So I didn't need to import foundation in the person file either. So
You
maybe, is that because I imported it elsewhere that it still works?
could be. I'm not quite sure what you were actually doing there. Maybe next week, let's figure out a protocol for screen sharing so that we can debug as a class. But right now, let's just stick here. All right. But here's an important little conclusion. If I import foundation into this interface, it's going to be available wherever I import that file, because I import the interface that I define here and everything else that's imported. How do we feel about that? Because person imports foundation, we import it here implicitly. Cool. All right, made an IVAR. We did it. This thing. Now Phoenix, I want to make a property called burrow. How can I do that?
You can say at property and a string burrow.
Cool.
Well, on the star before burrow.
What's that star called?
I do not know.
All right,
Okay, pointer.
cool. Thank you, Eric. Thank you, Liana. Again, we need a pointer when referring to any object. And a string is an object from foundation. It's not a basic type like an int. Okay, perfect. Now Jack. Hi, Jack.
So,
How are you?
doing well.
Good. All right, we've got one last thing. an instance method called whatStack.
Okay. Do you want this to be a void method?
Why would you say that?
Don't. I think it's just going to be a print function, and it's, or maybe something else. I don't know.
Okay.
We
So
could print it as a string, or we could print it as a, what is this burrow? Yeah, it is a string. So, I mean, I'll create a function called print, or just or what stack, or print what stack.
yeah,
So I guess I'll just write what stack as the name of the function, and then put the curly braces so I could implement the print statements inside it. And I'll write nslog at burrow, or yeah, shouldn't just be, yeah, well, the name of the burrow, just write burrow, yeah, whatever that is. And then after the comma is the name of the property. I think that's it. Well, don't forget the semicolon, but that should be it.
okay. I have actually, Liana has what could be rephrased as a question here. Do we want to do this here? Look what file we're in.
Is this the interface or the implementation? Oh, yeah. Right, it's an interface.
Cool.
Okay. Then you just write print, void print. Oh, void what stack or something.
Cool.
Yeah, that's it.
So we just give the signature for that instance method. Perfect. Thank you, Jack. He ran away again. Okay, so we know what stuff we want, but now, all right, I got to implement that stuff. Do I need to do anything for this property? What's the process of like getting some out of the box functionality for a property call?
Can you ask that again?
Yeah, there's a term for what the compiler does to make a property work for us without any implementation.
Are you talking about synthesizing?
Yep. And what does it synthesize for us? It synthesizes accessors. Eric W., what are the two accessors that we talk about all the time?
Get and set.
Awesome. So in Swift, we call them get and set. And here we call them read, write, get, set, perfect. And so what two messages are going to be synthesized by default for us with this burrow? What are they going to be called?
Sorry, can you ask that one more time?
Yeah. Specifically for this property burrow, what are the accessors called? What gets synthesized for us for this property? So they're read write, but what are they called? Jason, can I tag in? Jason. Okay, it's got background noise. Very convenient. Jason suggests we're gonna have stuff called get burrow, set burrow. We're close. So the convention will be for your read, it's just the name of the property, unless you rename it. And for your write, it's set and then capital letter, the name of the property. So if I have an instance of a fellow, if I look at their burrow, I get in return an NS string. And if I have an instance of a fellow and I send the message to set burrow, it's going to require an argument that's an NS string. Our setter, our getter, those get synthesized by default. Great. Before we go and implement it, what are some questions you have? Three, two, one. Boom, let's go on then. So according to this interface, the only thing we have to implement is this void function whatStack. Let's go take a look. So we'll start with the same signature. Then we open up the curly braces. And Jack, I removed what you wrote, but all we had was an NS log. Let's say I'll say, here we'll put the stack, and then we'll have the instance var stack. Say I wanted to add more information about the fellow here. What could I use?
When you say more information, what are you referring to? Just like a message?
No, so if we look at our fellow, there's a property burrow, there's an ivar underscore stack, but I actually have more variables available in my fellow.
Oh, right, because you're subclassing from person. You have all the properties from person as well, correct?
Sorry, one person at a time. Feel free. Just couldn't hear it.
I was saying that I guess is it because we're subclassing from person, so we have all the properties from person as well?
That's right. And so person gives us the ivars age and name. And so let's expand this a little bit. I'll say the person who is age years old works on the whatever stack the ivar stack is. How do we feel about that? Well, this is called name. Sorry about that. Cool. So our whatStack will give us a really descriptive print. However, if I went and created a new fellow, so let's say I go to my main file, and we'll talk about how I might do this in a different way, but import fellow.h. I go and I make a new fellow called I don't know, Eric W. Say this is a fellow, we allocate some space to, and then we initialize it. Let me see here. How many initializers do we have in this overloaded init? Yep, Rod, you see two. Let's talk about those two real quick. This init comes from NSObject. So it's inherited not from this fellow's superclass, but from its superclass's superclass, NSObject. Then this init with name comes from the superclass of this fellow, which is person. So we have two different initializers. However, these initializers won't get us all the information we need for this fellow, because we also have an IVAR that's initialized in here called stack. So let's take a look at what happens when I use.
Wait, can you repeat that? I'm sorry, I did not follow at all.
Of course. So let's follow this fellow through, right? Fellow, if we go and look at its interface, is a subclass of person. And then person is a subclass of NSObject. NSObject has a function called init. And so anything that inherits from NSObject can call this function called init. So this person has the ability to create a new instance just using that init function. But then we also said, you know what, there's some specific stuff that I'll want to initialize a person with. And so we created our own init function, init with name and age. And so that's a person. And then the last step is, now that I have a fellow that inherits all of the properties and the methods of its superclass, that means it gets person's custom init, that init with name and age, and it gets the init from NSObject. So inheritance is just a direct line where if fellow inherited from person, which inherited from mammal, which inherited from animal, which inherited from, I don't know, creature, fellow would have all of those properties and methods defined by all of those superclasses. So it creates a direct line down. Fellow inherits two inits. One from NSObject and one from person. However, let's say we use this init. This init inherited from NSObject. What information is not added to a new instance of a fellow that we might want? Right. It doesn't give us name or age or stack. Similarly, if we use person's init on a fellow, so fellow Eric W here is a fellow, allocate some space, and then we init with name and age, Eric. And Eric, you can volunteer your age or I can make one up for you. Eric is 45 years old. 45 years young, I should say. Cool. Now, person's init will set the values for name and age, but don't know the stack. So let's take a 6-minute break, and when we come back, we'll make a custom initializer. Nima, before we run away, why am I getting an error here?
You don't have the semicolon.
Perfect. Thank you. So let's take a break. We'll come back at 11:11. Thanks. Okay. Yeah, let's get started on our custom init. So for fellow, we have available to us the two initializer functions that it inherits, one from NSObject, one from person. And now we want something that'll be specific to a fellow, because a fellow has this additional ivar right here. So in the header file, we can just add an instance type function. So a function returning an instance of fellow. That's this keyword again. Call it init with, make up some things. Well, we definitely need those things, name and an age that we get from a person. We also need one more thing. Definitely on the screen on the line between 14 and 16. Yep, we need a stack. So stack is going to be an NS string pointer, and that stack is going to be called, let's say, stack. How's that? See any reason for error? I do. Semicolons, amazing. My favorite. Thanks, Rod. Cool. All right, so that is the interface for our fellows custom init. Because we need to set up things specific to fellow instances. That's the interface, so that's what main will be interfacing with. But now we actually have to implement it. So here's the function signature for that. Let's look back at the custom initializer we had for a person, because maybe we can follow that template and we could, I don't know, adapt some of that and not have to write this from scratch. So if we look at the implementation for a person, so I'm going to move up here just so everything's together. When we initted a person with name and age, we did some stuff. Levi, can I ask you to walk me through what's going on inside of the block of the initializer here?
And I was totally paying attention.
Cool.
What is going on inside this block? Well, first you are calling the super init on the superclass's initializer on this particular instance, and then you are setting its ivar instance variables of name and age to the name and age that are there in the that are set as arguments, and then you're returning the instance that you just created.
Sorry, adding a note. That's great. So in order to initialize an instance of a person, there are a lot of notes there. In order to initialize an instance of a person, I need to call that init function from the superclass. The superclass for this person was NSObject. And that init had a lot of built-in stuff for us, which was great. Did a lot of the work of creating an object, an actual object for us that could be stored in memory and retrieved and transformed. And so we said self is going to be that object. And we actually don't do anything else to self because the rest of the values we had were for ivars. Those are not attached to self, those are not properties. And so all I did was in the space between setting up self and setting up our name and our age, I'm sorry, in the space between giving the value for self and then returning self, I just set up the ivars. Again, they are not attached to self. How do we feel about that? Levi gives a thumbs up.
A question, David.
Yeah.
So just to clarify, is the difference between an instance variable and a property in this case is when you create a custom init using the instance variables, you have an instance of your class with all of those variables already set. And the difference here between a property is a property you would have to update after you've created an instance.
So a property we could update after we have an instance, but we could also do in this init. So for example, if there was a property, if we had a property called height that synthesized height and set height accessors, what we could do is we could send a message to self saying set height based on some value coming in. Argument to this function, maybe. And so this is what we're used to as an instance method, where I'm sending a message to an object. That object happens to be self, so an instance of this type. Self is a keyword that just lets us create an instance of this. So just like inside of a Swift class, if I said, I've got a person class and I refer to self, I'm talking about any instance that I just created of this class or this struct. Same here for our custom types in Objective-C. I'm initializing self initially with the inherited initializer from NSObject to make sure it has all the stuff it needs. I could not do that, but then I wouldn't have a bunch of behavior I need. Then if I had properties that I wanted to set in the initializer, I could just send a message to self here and then set that properties value. So we could be setting properties values and even getting properties values. Like this would be obnoxious, but I could totally do it. I don't know. Age is equal to self height, which is not good, but can be done.
Can you clarify then what the, like when would be appropriate to use an IVAR versus a property? Because it seems like they're interchangeable in many ways.
Well, there's one difference, right? Accessors allow us to access these values on an instance. So if we look back at the person we created the other day, when we had a property for a person called age, instead of an IVAR, we could set that age when we have a literal instance. So there's an encapsulation thing going on here with IVARs, where we're keeping all that stuff private. We are keeping age and name private. So not anyone can just go say, hey, for a person, I want to be able to set the height and then read the height. Instead, we're only exposing the functionality that we want, which in our example was we wanted to be able to read someone a pop pitch. We didn't want anything else to be available to someone using the interface for our person. So we made them IVARs. But if I wanted someone to be able to set them and access them directly, then I would probably have it as a property.
So for IVARs, the only time you would access them is when you create the instance of your class, whereas
Well,
a property can be accessed anytime.
So we could have an indirect way of doing it, where if I said, if I wanted to have a function called, I don't know, change name, or something like that. I could just have a function effectively doing what set name would do if it was a property. I could reassign void change name. I could say this takes in, I don't know, what should we call it? Name? Okay. So if you remember, these are not function names, but instead they're the names of the first argument. Change name to, and then this could be an NS string. Just say Ivar name is equal to change name to this guy right here. So I could set them up later on, but the whole point is, if I don't want the actual values exposed to the end user, I don't want to use a property.
IVARs are essentially private properties.
Mhm. That only exist within the scope of one individual, whatchamacallit, instance. Cool. I'm gonna move this up, just write it up a tiny bit. Other functions can change or use IVARs, but the implementation is hidden, encapsulated. All right, let's go back to our fellow. Just like with a person and its init, what we'll want to start with is, hey, we could actually get our supers one of those inits. Which do you think would be more confusing to use?
You said more confusing to use?
Yeah, which of these inits would probably create more confusion if I looked at the implementation?
I mean, well, the init with name is requiring a string name and an age int, so that's pretty simplistic. Like, I believe the regular init will probably be more challenging. I don't know.
Okay. Let me ask this a different way. Do you find this or this is choice one? Or if we initialize, so this is using NS object init. Two, person init. Self is equal to, move that out in a second, super, init with name, which is name, init with age, which is age. And we could say stack is just stack. Which do you prefer?
I prefer choice two. It's less code, it looks more readable, personally.
Cool.
I might go with choice two as well, just because you know that flow is subclassed of a custom class.
Yeah, I like that. So we could say this uses the direct ancestor of our class, whereas using super init is going somewhere way up the inheritance chain. or the initializer. Cool. Now I've got an error here. What do I do? What is the return type of this function? That's right. It's
You need to return itself.
cool. Let's return self. And again, self is just an instance of fellow, the built-in keyword. Sounds great. All right, let's make a fellow. You ready? No? Okay. So let's make a fellow. I'm going to steal what we have going on here. I'm going to be really lazy because, again, to send this message to an instance of our fellow, all I have to do is tell it what the arguments are. So, Eric W., what stack are you? Can't hear you, sorry. Eric. All right, what's the name of this class? Can anyone shout it out?
6-1.
Say that.
1.6 backwards.
What?
1.6 that reverse.
1.6. 1.6. That reverse. What? What are we learning? Come on, you got this. We're learning Objective-C, we're learning Swift, and what is that all in the software development programming paradigm of? Yes, our stack. Thank you, Levi. Our stack is iOS. Has anyone here ever made an iOS app? Even maybe over a few months? Okay. Well, let's see if our inheritance works for this Eric that we just made. I'm going to send a message to Eric. What's that message called? Oh, that's right. It's the void message, what stack? And this should print out some stuff for us if it works. Let's run it. Cool. Hey, Eric. It's so interesting. So you're a fellow, and I just asked you what stack. Well, Eric, and I, for some reason, need to know your age. You work on the iOS stack. That's great. Levi asks us for his pop pitch, and I'm going to spare you doing that digitally and instead just call it in our program. But if you really want, you can jump in right now and give us your pop pitch. I'm sure everyone misses them. No? Okay, that's okay.
No, thank you.
I understand. Cool. So our what stack prints first, and then our pop pitch prints. Amazing. This is just like creating functions that we're used to. All right, though. This is an inheritance-based language. But the thing is, if I want to provide a template or a blueprint for some behavior without actually implementing it, I can do that in a way that's similar to Swift. What's that called in Swift?
Can you repeat that, David?
Yeah. So this is inheritance. We're playing with inheritance. A fellow inherits from a person, which inherits from an NS object. But it does give us the ability to do something familiar where instead of just passing behavior, we can instead provide a passing behavior and properties, we can instead provide a blueprint for behavior and properties.
A protocol?
Yes, let's make a protocol. Because what I want to be able to say about any person, is I want to be able to say, whether or not they're comfortable. All right. And that's great because we can just make that the name of our protocol, comfortable. If I hit new, and I go to make specifically a new Objective-C file, you see I get all these options. Protocol is the one we're looking at. Category and extension are going to look pretty familiar, and we'll do them at pretty much the very end of this class, because you'll see what I mean. So let's call this protocol comfortable. What file did this create for us? Even though we selected Objective-C file, it created a .h file, but why? Why can you think? Selected an Objective-C file, but got a .h file when make the protocol. And that's right. Sunny says, it's just a blueprint. There's no implementation. There's nothing that needs to be in a .m file here. We just need to provide what an interface for this protocol would be. It has the @keyword protocol, which is basically just saying, we'll define this wherever it's used, but it's basically the same thing as using an interface like we do in our .h files here. So for a protocol, we only need the .h file because, like we said, its implementation is going to be somewhere else. Cool. What can we say about this comfortable thing? Ooh, question.
Sorry, one more time, David?
Yeah. If we're talking about real life and we want our code to be object-oriented and abstract out stuff about real life, a protocol is a set of, a protocol is properties and behavior that we can give to an object. So what would make someone comfortable? How about if we just had, Rod suggests food, that's great. What if we just make a property called is comfortable? I don't know, just making this up together. Well, if we got a property, what does my interface need to know about that property? Yeah, it needs to know the type. And is comfortable might tip off to you. It's an A or B, a true or false, a 1 or 0 situation. It's a bool. So just make this a bool. Is that how it works? No. What about this? I don't know. How does a bool work? Is there anything called like an NS bool? I don't know. Maybe. Thanks, Eric. What do you suggest? Something like that? Cool. Is this the right way to set this up? syntactically? Is this how we set up a property? Is there a place we can refer to see? It's pink, so it means something. Thank you. Where can we look for just what a property should look like? Where have we had a property in this project?
In the header file?
For which one?
Person.
Cool. So person used to have a property. There's an NS string called name. Great. I would caution, if you're setting up properties, just make sure that you keep the type of that property outside of parens, because as we talked about, properties can have stuff like read only, properties can have stuff like make sure it's a copy, so on and so forth. So just make sure when you're setting up your property that when you're giving it its type, it's outside of parens.
I have a question.
Yes.
Can you explain the reason why it has to be outside of parens?
Yep.
I didn't really understand that part.
Yeah. Let me pull it up. So when we set up a property, which again, our compiler synthesizes a whole bunch of information for us. I would bring us through some documentation. Objective-C, property, attributes. Liana's raising her arms in celebration and victory. And that's great because she froze. Cool, now she froze again. All right, let's look at this web page here. So when you declare a property, there's sometimes words in parentheses that give some special attributes to your property. A couple of them we talked about are the atomic versus non-atomic, which have to do with keeping our stuff thread safe. You'll note this is an important specific that we'll talk about when we do iOS development next week. Yay. You can also set up the access. All this goes in the parens of the property. So if I go back and I look at my Xcode, I could say in here, this will be a copy, read-only, non-atomic property. And then when the property is created by the compiler, it'll synthesize all that for us. So that's nice.
Can I ask a question?
Tia?
When we're working with Swift, we can do the documentation within Xcode. Does that work in here too?
Yep. Now, it's not as verbose or nice to look at, but it'll show you where you're going. That's nice. And look at this craziness. What is going on there? We'll talk about that in just a second. But first, let's make our protocol is comfortable. And let's just give it a quick instance method. I don't know. If I'm comfortable, I'll say, so NSObject does not, NSObject, yes, Sunny will look at that in just a sec. NSObject is a poorly named pain in the butt. So let's just have a void function here called are you comfortable? Okay, seems simple enough. How do you think we can use?
Fine.
Hello?
Hey, do we need a pointer to it's comfortable? And if not, why?
Who can answer that?
Couldn't hear the question. She was cutting out.
Yeah, do we need a pointer to this property is comfortable? And if so, why not? What I'm hearing is, yeah, this is a basic type that we get in Objective-C. And most of our objects that we use are preceded by NS object, the NS prefix, or the ones that we make. Those need pointers, but this is a pointer, I'm sorry, this is stored directly in memory, and we don't need a pointer. And yes, Levi, it is super confusing. So this is one of the few basic types that we can use. I'd say as much as possible, just use ints and bools and stay away from the other ones, because, reminder, car is not character like we're used to. So just word of thumb. Is that rule of thumb? That's the thing. All right. I like Newell. Okay. Rod asks, they've seen bool both capital and lowercase. Let's see where this one's from. Computer. Oh, that's all caps. Screaming at me. CPU so slow. Agreed. This bool is different from the other bool we're used to. I'm fairly certain that this is a constant that's available in all scopes, as opposed to a basic type. But don't 100% quote me on that. If we want an actual bool value, we'd use lowercase b. Lowercase o, lowercase o, lowercase o. All right. Why did we drop the parentheses? Parentheses. Where are you saying that, Tia?
When we were establishing the bool in the other file, or lower in the file.
Yeah, can someone tell Tia why we didn't use parens here as I commit and push this?
The parens are used if we're making like a function, we put a type in there to indicate the output. But when we make a property event, like if we wanted to have specific functionality of that property, like if we only wanted to be read-only, that's stuff that we would put in the parentheses after the type.
Got it.
Hang on a sec. I'm going to push this to GitHub so everyone has our protocol. Hello. Okay, so the way we conform to a protocol is not colon, I'm sorry, but rather we say comfortable. Hey, why isn't this going to work now?
Do we have to import the protocol?
I think so. I'm going to be constantly importing interfaces. So that protocol that we got there, comfortable.h, now it can read that, see it. Cool. What do we see about comfortable? What are we used to with a protocol in Swift?
Sorry, one more time.
What are we used to seeing when we first say, hey, this type should conform to a protocol in Swift?
It yells at us for not having the property functions in the protocol.
So we don't see that here. Kind of a pain, right? Let's see if we can change up our protocol a little bit. So you remember how in some of our protocols we can just include some things but not other ones? That's available only on Objective-C or classes. And so we can start implementing that here. Let's say I wanted to have some optional property, I don't know, sweat level. We'll have that be an int. I wouldn't be required to implement sweat level, but I would be required to implement property and are you comfortable? I'm sorry, this property is comfortable and the instance method, are you comfortable? So, interesting. Still doesn't require me to do it. Anyone have any ideas why?
One thing that comes to mind will be, does Objective-C make everything in a make everything optional?
Does Objective-C make everything optional?
In a protocol.
Well, then what would be the point of that required keyword? Right? Thoughts? Guesses?
Do you have to write at end after what you want to be required?
Interesting. Right here? Like that? I don't know. Try it out. Guess not. Dang. What else do we think? So I don't need these ends. Does it just want the required stuff in the implementation? Interesting. Why do you say that, Angela? Let's go look at our header again. Got yellow stubby. I didn't know that was the new technical term. Yellow stubbies in the implementation. Oh, that's right. This is the interface. You don't have to implement anything on this protocol. Just like with inherited properties, methods, you don't have to list them. Right? This interface for person also interfaces with the NS object to figure out its properties, and also interfaces with comfortable to figure out its blueprint. But none of that determines any implementation in here. Instead, we have to do that where we actually implement the person. So let's see what happens here. Should see some errors. Interesting. There are my stubs. Missed you guys. How you doing? Hey Stubby, where'd you go? Are you comfortable? Nice. And then I also see this guy. Auto property synthesis will not synthesize property is comfortable declared in, nope, hold on, let's go back. Declared in the protocol. Add a synthesize directly. So because our interface, as opposed to our protocol, actually provides an instance rather than a blueprint, when we get properties from, say, a person, like we did before, our compiler knows how to synthesize them. But when we are using protocols as defined, when we're using properties as defined in a protocol, we actually have to provide the synthesize directive. Nice thing is we still get stubbies, just like we're used to. And here we're explicitly telling the compiler, synthesize something called this. And then what it will do is the magic of, sorry, I know I'm scrolling a lot. It'll do the magic of going and finding out where that exists in what interface. And that interface is wherever we set it up. So because we conform to comfortable, we just have to say, hey, we have a blueprint for a property, but we haven't actually created it, and just go ahead and synthesize it. We provide that manual command. I know it's really fun. Okay. Now I'm just going to have, are you comfortable? And out, I could tell you that statement, I am comfortable, is then right here, I have a property is comfortable. I know this is a really cool way of setting it up. Where could I find out on an object if that person is comfortable? We'll just set it up. Yeah. I could send a message to self and say, am I comfortable? what do you think this is going to be about? What do you think this yellow error is pointing out to us about is comfortable?
Probably the wrong type because the add symbol is for string, but it's comfortable as a bool.
Yeah, so is comfortable as a bool. The add is actually for any object. So in a string like we're used to, we've been doing a lot, that's to add in any object. For is comfortable, we need a different kind of flag. I don't know. B, Q, W, D. Phoenix, what do you say D? We use it for other basic types. It's a pretty good one. I don't know, let's try it out. It's not really an important thing here. Levi says, do we need self? I'm gonna say yeah. Or what were you thinking? Like that? Interesting. Like that, Levi? Yeah. Well, not for me. Why does this work though? So a little beyond what we're doing, but property actually synthesizes ibars for that property. So within the scope of any person, there is an ivar is comfortable. Whoa. And that's where the actual value of that property is stored. So when I say set is comfortable, I'm setting the value of the ivar. This message, self is comfortable, is accessing that. That's why we call it an accessor. Ooh, amazing. Does that mean properties are always more expensive, Phoenix asks? Yes, absolutely. Properties are adding a whole bunch of functionality that you may or may not need, whereas an ivar just is exactly what you've set up. An ivar is either an int, an NS string, whatever it is. A property has to know about its setters and getters. It also has to know about all those attribute options you could put into it. So right now we're using the quote unquote private property, or the ivar is comfortable. Cool. We set this on a person. Let's go look at our Eric. Hey, Eric W. Are you comfortable right now?
Yes.
Nice. That's great to hear. So we set this here because why? Just like with anything else that a fellow gets from a person, what also works here? Yes, inheritance. So that protocol is implemented by a person, which means the fellow inheriting it gets to use all that functionality. That means just like, let's see if I can get this out. We've actually seen this plenty of times because we're used to it from UIKit. Hold on. Do. Go back. Ah, crap, I deleted it. But let's see. If I import, yeah, that's a good one. If I import UIKit, I have it. I don't know if it's available. All right, let's look at a different place. I'm going to create a new playground. There. My playground. Import UIKit. Let my view equal a UI view. Now we go and we look at UI view. When I use a UI view, let's look at it, inherits from a UI responder. So in the Swifty way we're used to looking at it, it inherits from a UI responder, but then it conforms to all these protocols, all of them. And if I created subclass, then in this new view, I would get all of the behavior implemented in a UI view, including its protocols. So anything implemented in a superclass, whether it's directly in there, whether it's conforming to a protocol, anything in there is available to its subclasses. Any questions right now? Okay. So what I'm going to ask is that you all take, let's start with 15 minutes again, and create another protocol. And we're going to call that protocol employable. And we are going to add a property, is job ready. And then we're going to have that fellow conform to employable. So I'll put that in our chat. Stop recording for a little bit. Create a protocol called employable with the property is job ready, have fellow conform to the protocol employable. We'll come back at 12:22. So yeah, let's go back. Here we've got our protocol employable. Now you said in the fellow.m, we want to do something. Let's ask for help. What do you think you should do next? I can help you out.
I
Emphasize.
think you want
Yeah, I don't know for sure that I want to put it in there. I just wanted to say that.
Okay. Where do we want to put it?
I would think you'd want to put it in the header person file.
Cool.
The same where we put comfortable. You want to conform to protocol.
Let's go back to our instructions. Create an employable protocol with is employable, and then have fellow conform.
Yeah, gotcha.
Let's run to this header right here. Header for fellow. This fellow inherits from a person, and then how do I conform to a protocol? Tia, you're still here.
Yes, I am. Sorry. I was thinking that was a general question. My bad. I am still working out that detail.
Okay. Well, let's talk a little higher level. In this fellow, if I want it to conform to something in a different file, how do I get
Yeah. Hold on, where are you? You're in the fellow file. So we already have the person information. Do we just have to develop the interface and put the employable interface in there? So interface fellow person, then open the brackets and put employable?
this?
Yes. But we also have to import employable, right?
Yeah, perfect. So we're going to import employable. So we have the interface for employable providing that blueprint to fellow. And then, if you recall, that is all we do in the interface. Where do we set up the actual employable stuff?
So for comfort, we did it in the M file for person, meaning we should do it in the M file for fellow.
Cool. Yeah, great. So in the fellows.m file, the implementation, that's where we can implement all the stuff required by that protocol. Let's go look at that protocol again. There's a required method and a required property. If I go to fellow.m, let's build it and see if we get any errors. These look familiar. So this guy right here, are you employable? Oh, it's familiar, right? And then what else filled in here?
Are you comfortable?
Yeah. And so by default, and that's where we have to be careful with our inheritance, any protocols that our class or our superclass conform to get thrown in as stubs. We don't have to implement are you comfortable because it's already implemented by the superclass. But we could override our superclasses are you. We could. Let's just say we don't. Protocol stubs include all protocols this conforms to, including those of this class's superclass. Cool. So I'm going to comment that out. How are we going to determine are you comfortable? I'm sorry, are you employable?
With a bool?
Yeah. So where does that bool come from?
Before we do that, where we are right now, aren't we supposed to be designating like the print statement for that?
Like where my cursor is?
Yes.
Yeah, exactly, we are. What do you say?
Because the bool needs to be implemented someplace else.
So we are going to use the bool somewhere else. But what about this function leads you to believe it'll be void? I'm sorry, I gave away the answer. We're going to print from this statement. And so it's good that this is labeled void because that lets us know we're not returning anything, but we're doing some work in here. And that work is probably some kind of NS log, right? What do you want to print out? Use a literal.
Yeah. Basically, we need to say this person is or is not employable. So the, what is it? The at parentheses at for the name.
Mm-hmm.
The parentheses at comma is employable or I don't know.
Okay.
Right.
And there's a reason this isn't available to us. Tia, I want to thank you. High five, clap, clap, clap. You did great. I'll take it over from here.
Thank God.
So this as employable, or even, we said this is an IVAR, even the property is employable. Well, where are we going to get that? Oh, our protocol. That's great. But like we said before, there's no IVAR. I'm sorry, there's an IVAR holding the value behind every property. And that's just accessed by the accessors, whether you're getting or setting, whether you're reading or writing. And so what the compiler is not going to know is how to synthesize it until you add the synthesize directive. So let's just synthesize that here. I'm going to add that above the instance methods. What we can also say is synthesize is employable as underscore is employable. We're setting the name for the IVAR there that backs up our property is employable. So we can do this. The synthesize directive itself is just saying, make sure that we have the IVARs to back up any property. But we can also say, actually, that IVAR should be called something else. Here, we synthesize our property to have a specific IVAR different than the one it would. So it is fellow employable. And then here, I could use that IVAR, and I could say, we'll start with the name. Could be are they? First argument will be the name of our fellow. And we can do something else in this spot. What's a logical way or a way of using conditionals that we're used to that we could set a condition based on this value and then return something different? Let's say right in this space, I want to check if the fellow is employable. If they are, return a string that says yes. If they aren't, return a string that says no.
Are you referring to a ternary operator?
Oh yeah. Let's see if we can use the ternary. Yes. No. Expected parens. That's because I need to close the statement here. And then to add it in there, I get an NS string, right? Because I'm using the literal notation. Let's see what happens. Okay, so we got our fellow. Let's go back to main. Now we can call another instance method on Eric. Are you employable? What are some predictions of what's going to come out here? I'm going to comment these out. Any predictions? What's going to print? The whole thing's going to be no?
Do you need to set the property like is job ready or is employable?
Oh yeah, that's right. I need to set up the property set is job ready. Whoa, where'd you go? Is employable. Eric, how do you feel? I know this is a very harsh yes or no question, but are you employable? All right. Everyone says yes much more emphatically than you do. I also think you're employable. Great. So I need a semicolon. What? All right, we've got our fellow. His name's Eric. Hi, Eric. Great having you. And let's see. Are you employable? My computer is so loud right now. Amazing. Eric, that's great to hear. I'm so happy to hear it. Cool. All right, so we've got our protocols, we've got inheritance using protocols. What are some questions you have?
Can you just go back to the fellow main file for a moment? Stay there.
Yes, ma'am.
Got it.
You have a question?
It's not a question. I just wanted to see how you did the ternary operator. But I do have a question from way back in the beginning of this lecture when I brought up an enum. Do enums exist in Objective-C?
They do. Yeah, you could definitely set up an enum. They're clunkier, but they exist. I do want to hop into something else that's important for this lecture, but there is documentation. I do love you. More. Any other questions?
Wait, what did you just say?
I said I also love enums, and then I blew a kiss into the air to enums.
Oh, okay.
Yes. Okay, one last thing I want to do real quick. If you remember when we were making Objective-C files, they gave us a bunch of options. One was a protocol. The other two were categories and extensions. Extension might be familiar, and it works pretty much in the same way that we're used to. Let's say I want to create an extension for a person. What does a person have? Let's call it, I don't know, number of digits. No, that's morbid. Hands, pet, any other suggestions? It's a nice thing to share about a person. Fab food, love. Okay, let's go with fab food. Favorite food. So what this allows us to do is, I'll get rid of this stuff. You see again, because we use this Objective-C file, and with the Objective-C file, we said what this is an extension to. So I went into Objective-C, I selected the class there, person. It has this little just empty parens, and that means we're extending the class. And the name of the file is automatically created in something that might look familiar to you. So when we've extended types in Swift, we've usually named that file the type that we're extending plus, and some people call it extension, but a better way to do it would be plus and whatever like category of functionality you're giving it. This is how we do an extension in Objective-C. Let's say property, and I'm just gonna keep it as a string right now. For simplicity, I'll call this fab food. Cool. Now, this is the one time where it's okay to be lazy. Don't tell anyone. Someone might disagree with me. It's okay. Jack looked at me and was like, no. I can add further implementation to my person, or do I even need to right now? With a property, do I need to implement anything else on it? I see some shaking of heads. Angela says hats. Sorry, I missed that one. Nope, and that's because it gets synthesized. But if I had, say, an instance method, it's the same lame thing again, void. What is your fab food? Then I could just implement it right down here. Same extensions you're used to, different way of setting it up. There is one other option though that I do want to share with you because I think this is important. I think this is generally how we have set up individual extension files. So when we've done extensions, we've usually added those separate files because we want to extend a type that's built into a framework or a library that we didn't define. So let's say I wanted to extend NSDate. The way that we do this is we create a category. And it's going to look the same way. And I'm going to call this something really lame for simplicity. Print I. So I'm extending that built-in foundation type NSDate. And it creates for me two files. It creates the header file. And then in the header file, just like we see here in the .m file, in the header file, it says what the category we are adding to our class is. So we're saying we're specifically putting aside this interface for this category called print high. And that's where ultimately this convention comes from. NSDate plus print high is the category that we are extending NSDate for. So it works just like an extension. However, we specify it's this category. Can anyone think why? As I take a long sip of water. Water. Anyone got any ideas?
Is it because we can't directly implement in a state because it's a built-in object? And so we would have to implement print high category within for an estate?
Yeah. Sounds about right. NSDate is not our interface. We get it from somewhere else. It's this built-in package. These angle brackets indicate that this is a framework that we have available to us, but that we didn't create. And so if we want to extend anything in those, we have to specify, like literally putting something in parens after the interface for a type, for a class, is that we specify that this is an extension. A regular extension just has open and close parens, but to indicate why we would extend some type we didn't create, we name the category. It's not incredibly important until you start building larger projects like you all have been doing for Capstone, but just think about how an extension works. To extend your own types, use empty parens. To extend a type that you haven't created, use a category. And this interface, of course, could have a void function printing something for our examples, because coding this takes forever. But before we break for lunch, what are some questions you all have?
I have a question about protocols. Can you also add the properties of a protocol into a custom initializer? Because what we've just been doing is setting and getting, but can we also create custom initializers with the parameters from protocol properties?
Yeah, absolutely. And what you'd need to do there is, a safer way would be to, if we synthesized is fellow employable as the name of the IVAR behind the property, then you'd probably set the IVAR instead of using property.setValue. So you were intentionally, sorry, I have a 3-year-old knocking on the door. She really wants to go to lunch too. Yes, if we were, can you give me 30 seconds? Sorry. You want to say hi?
No.
Okay, you're gonna say hi. This is Simone. She says hi.
Hi, Simone.
Bye, Simone.
Phone.
Can I help you?
Okay. Sorry. She's gonna help with lecture by jumping on the bed. So, yes, if the whole point of initializing our property, let me have to be quiet, please. Thank you. If the whole point of initializing our property with this initializer is to keep it private, then we would set the IVAR. And then if we access that property using either accessor, then what has been set will be available. Kind of. Maybe. Oh,
Yes, thanks.
okay. Thanks. All right, everyone. Have a great lunch. Enjoy your afternoon. We'll see you all for stand-ups around 2. Thanks, everybody.